Hello, my name is Chris Rumpel, and I like to study fluid dynamics at the University of Wyoming as a PhD student. And so exactly fluid dynamics, it's just the study of fluids. Anything that can flow is a fluid. Toothpaste is a fluid. Water obviously is a fluid, and so is air. So I like to understand how they move because primarily when I was younger, the shapes that happen in the sky just captivated me. So I followed that passion, and here I am. So today we're going to kind of discuss maybe the physics that's occurring that helps you create these beautiful works of art. So take my little brush here. Again, getting just enough on the tip, pushing it into the surface of the fluid. Didn't get enough. So I'll add a little bit more. Green and orange. Let's try that. I like experimenting. Okay, as you can slowly start to see, the color expands out on the surface and it doesn't appear to go anywhere but that. So as you have your pen or your brush and you're pretty perpendicular to the surface of the water, you'll see that it pulls out from the tip. And there could be two things happening here. One, obviously you're normal to the ground, so gravity is at play, but also surface tension. And what is surface tension? You can easily see it when you throw water up into the air. It forms into bubbles. The water has an affinity for itself, an attraction, and so it tracks around itself and forms a connection. And so what's happening here is, right color. That when I connect with the surface, there's water already in this paint, and the paint itself might have an attraction to water, and because there isn't an abundant amount, the surface tension, the attraction from the surface, pulls the color outward like that. So, but a bad example, if I have too much, is that then we start getting some that float to the bottom. So the interplay there is there's a buoyancy issue, and that it clumps up enough that it overcomes the surface tensions and sinks to the bottom. And I always encourage, try whatever you want. If your desired result is to get all the paint on the surface to make this beautiful art, then go for it. But it's always good to dabble and make mistakes because then you learn. So let's keep adding more colors. Always remember, use the same brush, the same color. So then you can, as you add, maybe you move your brush stroke and you get more interesting shapes that occur. So now another cool thing is you can flip your brush and use it to stroke through the water to create a wake. What's a wake? A wake is something that you can hide from the wind from. So if you're in Wyoming and see those wind fences, snow fences, they create a wake that then slows the air behind it. And so that's all that really does, is because of the stickiness between this object in the water, it kind of pulls the water along with it and creates a wake. And you get to see these cool little spinning structures that we call vortices. And they create really cool, neat features into the surface. And as you can see, they kind of mix. They don't mix too well, and it's primarily because it's very slow. If I did really quickly, then then they would mix, and all these colors would then mix together and we get one complete color. So, like I said, encourage you to experiment. Let's do that. So I'm spinning really, really quickly in the middle, and as you can see, the fineness of each of these color contrasts becomes thinner and thinner and thinner, as opposed to in these other regions where it didn't move as fast. It's still very, less detailed in a way. So, there you go.
Sweet.
Furthermore, to show you can see that it's more mixed in the higher regions than it is in the slower regions. There you go. So in addition to the colors that we have, or the colors that we can make, we have two other fluids that we can add to our artwork here. And they are alcohol here, and on this right is soap. Another fancy word for that is surfactant. You can Google it if you like. So let's experiment and see what happens when we add these two to the fluid. So now we have somewhat of a shape here. We could add a little bit more color dimension to it. Now we're going to take our brush and we're going to add two different other fluids to the surface of our artwork. So this one here is alcohol, and let's see what happens. Isn't that cool? It looked like an explosion. So again, you can start seeing the surface tension pull out the alcohol, but then it puffs out in more of a kind of similar to those wakes. You get to start to see those little spinning structures called vortices. Whoa, that's so cool. So there could be a unique interplay between gravity, surface tension, and evaporation. So alcohol is very volatile. It dries a lot faster than water because it has a lower temperature, boiling temperature. So water, boiling at 7,000 feet, boils at 200 degrees Celsius, or sorry, not Celsius, Fahrenheit. And alcohol is much lower than that. I believe it's 97 degrees Fahrenheit, somewhere around there. You can fact check that. And so as it runs out quickly, it evaporates and pulls out of the water. That's cool. Let's try the soap. So, soap is completely different than the alcohol. Alcohol seemed to find its own path through the fluid as the soap pushed everything away. So this shows you that the soap doesn't like to mix with the fluid around it. And so what happens in the surface tension, as it pulls out, it takes up space and pushes everything out.
I'm going to edit this, but put paint inside the soap circle, and it makes a ring of negative inside the paint. You can alternate the soap and the paint.
Sure. So now, let's say we can do different things. So now we have a brush with soap on it and a brush with paint. So let's add some paint and then some soap. Pretty cool. That's so cool. So now, let's see if we can add some alcohol. Oh, that's pretty cool. Let's see what that looks like in the final product. So there we go.